All right, these notes over areas of regular hexagons is very similar to the areas of regular triangles or equilaterals. Same labels, except the triangle, if you can tell, is in a different position. But I have labeled it with the angle measurements, which I strongly encourage you to do in your notes. And then I've also labeled the sides to give you an idea that your apothem will now be x square roots of 3 and not x. So please take a moment to get everything labeled, and then we'll continue on. All right, looking at example 1, again, our formula is the same. So we do have to find the perimeter of the shape, and hexagons have 6 sides. We also have to find the apothem if it's not given, multiply those, and divide by 2. So looking at the information provided in example 1, we are given the apothem, which is 4 square roots of 3. Since x is equal to 4, I know that part of the side or half the side length is 4. So if I double that, my 2 4s give me 8. So the perimeter of the hexagon is 8 times 6 sides. So we're looking at a perimeter of 48. Now to find the area, we're going to multiply the perimeter times the apothem, and divide that by 2. So this is where you can multiply 48 times 4 and divide by 2, or you can reduce or simplify first. So I'm going to simplify 48 divided by 2. So now I have 24 times 4 square roots of 3, and 24 times 4 is 96. So the area of our regular hexagon is 96 square roots of 3 centimeters squared. Okay, to work example 2 out, the information given, they've taken the triangle and just flipped it, but it's still the same information we need. So they did give us the apothem, which is 6. Don't forget the apothem in hexagons is the length x square roots of 3. So we're going to have to find the value of x. So I'm going to set 6 equal to x square roots of 3. Different ways we can solve it. We can square both sides. We can divide by the square root of 3. The method that I have been sharing is that if we divide both sides by square root of 3, we now have that canceled out. So we have 6 square roots of 3 times square roots of 3 over square roots of 3. And that's going to give us 6 times the square root of 3 divided by 3. Simplify that. 6 divided by 3 is 2 square roots of 3. So this small or half of the side length is 2 square roots of 3. Then we're going to come back and double it so we can find the side length. And if we double 2 square roots of 3, we get 4 square roots of 3. And we also need the perimeter. So if we have the side length, then we're going to take this side length times 6. So the perimeter is 24 square roots of 3. And now we're going to find the area. So I'm going to take my perimeter times the apothem and then divide by 2. So we can simplify it in different ways. I'm going to reduce the 24 and the 2 first, so that's going to give me 12 square roots of 3 times 6. So our final answer to this one is going to be 72 square roots of 3 inches squared. Okay, looking at example 3 in the information given, I'm given the side length, so that's going to make it easy to find the perimeter. So perimeter is going to be 12 times 6, which gives us a perimeter of 72. Now I need to determine the apothem. which if that's 6 and we know that it's turned, then x is 6, and that means our apothem is going to be 6 square roots of 3. So to find the area, I'm going to take the perimeter times the apothem and then divide by 2. So our answer to this one is going to be, and again, you can multiply 72 times 6 and then divide by 2, or you could reduce first and do 72 divided by 2, which is what I'm going to do. So 36 times 6 square roots of 3. It is going to give us, let's see, 636. I'm getting 216 square roots of 3 centimeters squared. All right, looking at example 4, and it should be getting a little bit easier. The information given is the radius of the hexagon, which some of you are calling the hypotenuse. Since it is a 30, 60, 90, the hypotenuse is twice the length of the shorter side. So if that's 14, then this is going to be equal to 7, which is going to make it easier because then our apothem or apothem is 7 square roots of 3. We know that if that's 7, and then I got to double it, so the side length is 14. So the question is the radius of a regular hexagon going to be the same as the side length? So if we do other examples, hopefully that'll work out. And then you can tell me tomorrow in class. So I'm going to do area equals apothem times the perimeter, so 14 times 6 is 84. Divide that by 2. Again, you can reduce first, or you can multiply and then divide by 2. I'm going to reduce the 84 by 2. So now I have 7 square roots of 3 times 42. Multiplying the 42 times 7, that's going to give me 294 square roots of 3, and our units are centimeters, and we're going to square it since we're finding the area. Okay, we're almost done with the notes, and again, I hope it's getting a little bit easier to determine the area of the regular polygon, which we're only working with hexagons in these notes. So with the information given, they're giving us the radius, or what we're calling the hypotenuse, which is twice the distance of the shorter leg. So we know that if that's 10, then the shorter part is 5. And since the apothem hits the side at the midpoint, then we can double it. So we know the side length is 10. So to find perimeter, we're just going to do side length times number of sides, which is 6. So our perimeter is 60. To determine the area, oh no, we got to find the apothem. So that is x square roots of 3, so that was easy enough. So we're going to do area is perimeter times apothem divided by 2. So I'm going to reduce the 60 and the 2 first. So that leaves me with 30 times 5 square roots of 3. 30 times 5 is 150 square roots of 3. And since it doesn't have any written units, we're just going to put units squared. Okay, last example of the notes, and we don't have a picture, which I don't think you need one. If you want to draw one later, you can. But since it is a hexagon, it's a 6-sided shape, and the perimeter is 120. Keyword being regular, then I can take and divide 120 by 6, Each side length is 20. So with that given information, if the side length is 20, then I can divide it by 2, which leaves me with 10. So I'm just going to put one part of a side. So this is 10, this is 10, and we know that that's the value of x. Our apothems are the short leg, times the square root of 3. So our apothems 5 square root of 3, and our perimeter is 20. So to find the area, perimeter times apothem divided by 2. Okay, so I'm going to reduce those two first. So I'm left with 60 times 5 square roots of 3. 60 times 5 is 300. So our answer to this problem, I'm getting 300. You like my writing? I'm sorry, I gotta erase that. 300 times the square root of 3 centimeters squared. All right, I hope these notes were easier than the area of the regular triangles. But again, you're having to work with your 30, 60, 90 properties. Okay, so after viewing all of my notes that I've done, I've realized I've made a mistake on example 6. So when you come to class, my question to you is, what mistake did I make on example 6? Because the answer is not 300 square roots of 3 centimeters squared. So I'll be interested in hearing from you as to what the answer should be.